Hi Year 7, this is our fourth lesson for our topic of angles. In this lesson we're going to look further at parallel line relationships. So far we've learnt about the conventions in geometry and then all about angles at a point. And then last lesson we looked at parallel lines and we looked at corresponding, alternate and co-interior. So let's review what we learnt last lesson. When a transversal line cuts a pair of parallel lines, the following relationships are formed. Corresponding angles are equal, alternate angles are equal, and co-interior angles are supplementary. And this is what they look like. So corresponding angles will form an F shape. They're on the same side of the transversal line, but one's inside the parallel lines and one's outside. And there are four pairs of corresponding angles. There's the first one, there's the second, here's the third, and here's the fourth. Alternate angles will form a Z shape, and they're easy to remember because they're on alternate sides of the transversal line. And there's only two pairs of alternate angles. There's the first one, and there's the second. And then finally, co-interior angles, they're going to be both inside the parallel lines on the same side of the transversal. And they're the ones that aren't equal to one another. Remember those? They add up to 180 degrees and they make a C shape. There's only two pairs of co-interior angles. There's the first one and there's the second one. So let's move on to today's work. We're going to use what we just learned to solve problems. Here's the first one. Find the value of alpha, writing your reason in brackets. So let's have a quick look at this diagram. We've got parallel lines. We've been given an angle of 45 degrees, and this angle is labelled alpha. Now that's a pronumeral. We're going to learn more about pronumerals when we study algebra later this term. But a pronumeral is just a letter used in place of a number, and we've got to find out what the value of that letter is. So our first job here is to decide what relationship that 45 degrees and that alpha are in. Is it corresponding, alternate, or co-interior? What do you think? Well, they're on opposite or alternate sides of the transversal line, aren't they? So they're alternate angles. And alternate angles are equal when we're talking about parallel lines. So alpha is equal to 45 degrees, and here's our reason. Alternate angles in parallel lines. Now, why do we have to write in parallel lines? Why can't we just write alternate angles? Well, because if the lines aren't parallel, then alternate angles won't be equal. Have a look at these two. See, they're slightly skew-if. So in this case, alpha is not going to be equal to 45 degrees. And here's the thing. Angles can still be in corresponding, alternate, or co-interior positions on non-parallel lines. It just means that corresponding and alternate angles won't be equal, and co-interior angles won't add to 180 degrees. So let's try this one. So we've got an angle of 120 degrees, and we want to find the value of x. So which relationship is this? They're on the same side. One's inside the parallel lines and one's outside. They're the F angles, aren't they? What are they called? Corresponding. So x is equal to 120 degrees. There's our reason. Corresponding angles in parallel lines. Let's try one more. Okay, these ones are both inside the parallel lines and they're both on the same side. And we can actually tell that they're not going to be equal. Can you tell that? This one's acute, isn't it? This one's obtuse. So these are co-interior angles. And so M is going to be equal to 120 degrees. And there's our reason, co-interior angles in parallel lines. Now sometimes you'll be given an embedded diagram, and that just means that there's going to be extra information there. Sometimes you'll need it and sometimes you don't. So have a look at this diagram here. We've got parallel lines and we have a transversal with an angle and a pronumeral and then an extra line. We don't need this one, so ignore it. Okay, which relationship is it? They're on alternate sides, aren't they? So they're alternate angles, and alternate angles are equal. So x is equal to 72 degrees, and there's our reason. Alternate angles in parallel lines. But sometimes we do need the extra information. Can you see how this question is different? Okay, we do need this line because it separates this x and this 40. So have a look at the parallel lines there. We've got co-interior angles here. So this angle plus this angle equals 180, and that's what we're going to write first. X plus 40 plus 72 is equal to 180, and our reason is co-interior angles in parallel lines. And now we need to figure out what x is equal to. So 40 and 72 is 112. So something plus 112 is equal to 180. So x is equal to 68 degrees. Now sometimes in maths we like to work backwards, and we can use corresponding, alternate or co-interior angles to prove that a pair of lines is parallel. What am I talking about? Well, the lines will be parallel if I can find a pair of corresponding angles that are equal, or a pair of alternate angles that are equal, or a pair of co-interior angles that add to 180 degrees. Here's an example. State whether the following pair of lines are parallel or not, giving a reason for your conclusion. Let's have a quick look at this diagram. It's a little different to what we're used to. Firstly, there's no pronumeral that we have to work out. Secondly, there's no arrows on the lines to show that they're parallel. Now I need to stress, you can't just look at these lines and say, they look like they're parallel, therefore they are. Okay, that's not a valid reason. We have to use a geometric reason. The other reason we can't just look at it is diagrams are not drawn to scale. That means they can be drawn in a wonky fashion. So you can't just look at it and decide whether they're parallel or not. We have to look at those 62s and decide which relationship they're in. Do you know which one they are? They're on alternate sides of the transversal line, aren't they? They're alternate angles. Now, alternate angles are equal on parallel lines. They're equal. Therefore, the lines have to be parallel. So this is what we're going to write. AB is parallel to CD. And here's our reason. Alternate angles are equal in parallel lines. Here's another one. What do you think about this one? So which relationship is it? Both of the angles are on the same side, and one's inside the parallel lines, if they are parallel, and one's outside. So it's actually corresponding angles. Corresponding angles have to be equal, and they're not. So this is what we're going to write. BC is not parallel to DE, and here's our reason. Corresponding angles are equal in parallel lines. And one more. What relationship have we got here? We've got co-interior, don't we? And co-interior angles have to add up to 180 degrees. What's 129 plus 61? It's 190. It's close, but it's not 180. So they're not parallel. So we're going to write BC is not parallel to DE. There's our reason. Co-interior angles are supplementary, or you could say add up to 180 degrees in parallel lines. Okay, that brings us to the end of this lesson. In our next lesson, we're going to tie all of this together and we're going to look at some harder geometry problems.